In section 1.7, we're going to learn how to use equations to solve problems. So we'll just get right into an example. Let's suppose we have a piece of baseboard which is 84 inches long, and it's cut into two pieces so that one piece is 10 inches longer. Find the length of the shorter piece. So what you need to do when solving these kinds of problems is fight off the intuition that you just want to try to piece together an answer as quickly as possible. What we need to do is learn how to use algebra to solve problems. There are 4 basic steps in solving an application problem like this. The 4 steps are listed here. So first we need to define a variable that represents what we're trying to solve for in the problem. Then, using that variable, or variables, we need to write an equation. Then we need to solve the equation, and finally answer the question. So in this particular problem, we're trying to find the length of the shorter piece of the baseboard. So the baseboard is cut into 2 pieces. One piece is shorter than the other. So in step number 1 here, when we define our variables, I'm going to say the short piece of the baseboard is X inches long. And then we know the longer piece is 10 inches longer. That was given to us in the problem. So the long piece is X plus 10. Next, we know that the total length of the original baseboard was 84 inches. So that means that if we add the 2 pieces together, we should get 84 inches. So the equation that we're going to write is X plus 10 is equal to 84. In the 3rd step, now we just need to solve this equation. So combining like terms, X plus X is 2X plus 10 equals 84. Subtract 10 from both sides. This gives us 2X is equal to 74. Divide both sides by 2, and X is equal to 37. Now you have to be careful to not simply state X as the answer to the problem, because sometimes it won't be the answer. In this particular problem, we're asked to find the length of the shorter piece, and the shorter piece is X, and X is 37. So in this problem, X is the answer because it represents what we were looking for. But just to make sure you understand this, I could have asked you to find the length of the longer piece. And if I asked you to do that, you wouldn't set up the problem any differently. It's just that in the end, you would have to take X equals 37 and plug it into the longer piece if you wanted to know what that was. So let's go ahead and state the long piece is X plus 10, which is 37 plus 10, which is 47 inches. So if they were asking for that, you would have to make sure that you give that as your answer. So it's just really important to pay attention to what you're being asked to do. Let's try another example. So in this next problem, let's suppose a pizza delivery driver earns $50 per day plus $4.50 per pizza delivered. So the question is, how many pizzas need to be delivered for the driver to earn $158? So the question is, how many pizzas need to be delivered? So I'm going to go ahead and start with step number 1 by saying let X equal the number of pizzas delivered. Now we need to think, how does this person earn their income? So I'm going to brainstorm an idea here. We know that they make $50 per day plus $4.50 per pizza delivered. So their income for the day is going to be $50 plus $4.50 multiplied by the number of pizzas delivered, which we said was X. So now, step number 2, to write an equation where we can actually solve for X, we need to fill in a value for the income. But we know this value. They want to know how many pizzas to earn $158. So this is the income. So if we substitute $158 in for the income, we get this equation. And in step number 3 now, we just have to solve that equation. So if we subtract 50 from both sides, this gives us 108 is equal to 450 times X. And now we just divide both sides by 450. And this gives us 24 is equal to X. And since X represents the number of pizzas delivered, this is the answer to the question. So the driver needs to deliver 24 pizzas. In our next example, we have a geometry problem. It says that a rectangular pin has a length that is 20 feet longer than the width. If the perimeter is 400 feet, find the length and width. So in a problem like this, what we can do often is we can draw a picture to help us visualize the situation. So here we have a rectangle that represents this rectangular pin. And we know a rectangle has a width and a length. And so I'll label this side as W for the width, and this side is L for the length. And what we know is the length is 20 feet longer than the width. And so we can define variables by saying, let the width be equal to X, and then the length will be X plus 20. And this would be our step number 1. Now, I should note that you could define these variables in the actual picture itself, so you don't have to actually write down what I just wrote down. You could just go to the picture and say that the width is X and the length is X plus 20. This would work as well. Now we need to write an equation that represents the perimeter being 400 feet. And so to do this, it's going to be really helpful to have the perimeter formula for a rectangle. And the perimeter formula is P equals 2 times the width plus 2 times the length. And to get the equation that we need to solve here, all we have to do is substitute the values for the perimeter, which we know is 400. We'll put that in here. The value for the width, which we know we called X, and the value for the length, which we called X plus 20. And so if we substitute all those values in, we get 400 equals 2 times X plus 2 times X plus 20. And then step 3 just says solve the equation now. So if we distribute the 2, we get this. Combine like terms, 2x plus 2x is 4x. Subtract 40 from both sides. We get 360 equals 4x. And finally, divide by 4, and we end up getting 90 equals x. Now in this problem, ultimately, they want to know the length and the width. So to get that, we simply take our value of x, which is 90, and we plug it back into both of our definitions for the width and for the length. And so step number 4, the width is simply x, and x is 90. Now, don't forget, you should put your units on in the end. So the width is 90 feet. And the length, well, the length is x plus 20. And so that's 90 plus 20, which is 110 feet. And so our final answer is the width is 90 feet, and the length is 110 feet. This concludes section 1.7, but let's go ahead to section 1.8, because it is essentially the same types of problems, just with some slightly different formulas used. So one example here is that a pair of pants is sold for $84.50. If the store makes a profit of 30% at this price, what does the store pay for the pants? And what is their profit in dollars? So, fundamental idea here is that the store has a cost for the pants, plus they're going to add to that their markup, which is how much money they decide they're going to make on the pants. And this is going to equal the total sale price. And so we want to know, what does the store pay for the pants? That's the cost. So let's go ahead and define our variable to be, let x be the cost of the pants. Now all we have to do is take that information and substitute it into our idea up here. So the cost of the pants is x. Next we need to figure out, what is the markup on the pants? Well, we know they make a profit of 30%. But remember, a percentage is never used all by itself. A percentage always has to be multiplied to something. And so when we say they mark up their pants 30%, the 30% is multiplied by the original cost of the pants. So when we write our equation, in step number 2 here, the cost is x, the markup is 30% times x, and that's going to equal the total sale price, which is $84.50. So a couple of things here. First of all, remember, a percentage needs to be changed to a decimal before you can multiply it to something. And the second thing is, a percentage always needs to be multiplied to something. It's never by itself. So now all we have to do is solve this equation for x. So in step number 3, let's go ahead and make sure we take note of the fact that x is the same as 1x. So 1x plus 0.30x is 1.30x equals 84.50. And then we just divide by 1.30. And this gives us x is equal to 65. Now x is the cost of the pants. So this is the amount that the store pays. So now we just need to answer the question. Store pays $65 for the pants. Now the second part of the question says, what is their profit in dollars? So we know that they make 30% in profit, but what is the actual dollar amount of that profit? You can figure this out in one of two ways. You can either multiply 30% by $65, or the easier way to do it perhaps is just to take the sale price, which is $84.50, and subtract their cost. And if you do this, you get $19.50. So there's two answers to this question. How much the store pays for the pants, and their profit in dollars. So our next question deals with rate, time, and distance. And for this problem, it will be useful to know the formula distance equals rate times time. So we have a situation where two cars leave the same place at the same time. Their speeds are 30 miles per hour and 35 miles per hour. How long until they are 3 miles apart? Which is to say, how long until one car is 3 miles ahead of the other car? So we can draw a little diagram here to help us understand the situation. We have a starting point. We have one car is traveling 30 miles per hour, and the other car is traveling 35 miles per hour. So in the same amount of time, one car is going to go farther than the other. So in this diagram here, let's say this is the slower car, and this is the faster car, as the picture suggests. So the question is, when is the distance between these two cars equal to 3 miles? So we want to know, when is this distance right here 3 miles? So we need to figure out how far does the slow car go versus how far does the fast car go. So for a problem like this, it is very useful to set up a chart so that we can keep track of the information. Let me do that now, and then we'll come back to this problem. So here's a very basic chart that has a column for rate, time, and distance, and a row for the slow car and a row for the fast car. And I'm going to fill in as much information as I know. So the rate is how fast the car is moving, and the slow car is moving 30 miles per hour. The faster car is moving 35 miles per hour. Now they leave at the same time from the same place, so the time that they travel is the same, but we don't know how long. So I'm going to say the time is t for both of these cars. Now, once they travel for an amount of time t, the distance can be obtained by multiplying the rate times the time. So the distance that the slower car travels will be 30 times t, and the faster car will travel 35 times t. These are the distances that they travel. So in our diagram here, the faster car will travel a distance of 35t, while the slower car will travel a distance of 30t. And so by looking at this graph, this diagram, can you come up with an equation? Well, we know that this distance plus this distance must be equal to this distance. So what we're saying here is 30t plus 3 must be equal to 35t. And all we have to do now is solve this equation for t. In solving for t, we get t equals 3/5. And you got to keep in mind that the speed was miles per hour, the distance was miles, and so the time needs to be hours. So how long will it take for the cars to be 3 miles apart? It will take 3/5 of an hour. And just in case you're curious here, 3/5 of an hour is 36 minutes. And you need to be careful because sometimes they will ask for your answer in a different unit of time than was originally given. Do you understand how I got 36 minutes? Let me just talk about that for a real quick second here. So we take 3/5 of an hour, and to get minutes, we multiply that by a conversion factor. And the conversion factor is, we know that there are 60 minutes in 1 hour. And what happens is the hours cancel out. And what we get is 5 goes into 60 12 times, and 3 times 12 is 36. So that's how you convert 3/5 of an hour to 36 minutes. All right, so that concludes the lessons on sections 1.7 and 1.8. So now you should be ready to do some of the homework.